Hello everyone, how was your day? In this video we will talk about one measurement that are used to measure symmetry or asymmetry of data distribution. Have you ever heard about skewness? Yes, the topic that we are going to discuss for today is skewness. Before we learn more about skewness, let me explain to you the definition of skewness. Skewness in statistics represents an imbalance in asymmetry from the mean of a data distribution. If you look at normal data distribution using a bell curve, the curve will be perfectly symmetrical. And next, let me remind you of a few basic terms. First, mean is the average of the numbers in the data distribution. Second, median is the number that falls directly in the middle of the data distribution. And third, mode is the number that appears most frequently in the data distribution. In a normal data distribution, the mean is directly in the middle and top point of the bell curve. Let's take a look at this illustration. Imagine that Mrs. Thomas wanted to teach her high school statistics class on the first day about data distributions, standard deviations, and bell curves. She asked her 16-student class to secretly divulge their summer job incomes. Each student provides Mrs. Thomas with a piece of paper with their income. She rounds each income level to the nearest 500 and makes a chart. Now that we see the data on a chart, we can see that 4 of the students made about $2,000 in total over the summer. If we find the mean, we see that it is $2,000. The mode and median in this data distribution also happen to be $2,000. In a normal data distribution and perfectly symmetrical bell curve, the median and mean are always the same value. Take a look at the graph of the data, which represents a normal bell curve or no skewness at all. This means the data are perfectly symmetrical. Although it is quite unlikely for real-world data, as a general rule of thumb, if skewness is less than -1 or greater than 1, the distribution is highly skewed. And now we will move on to the properties of skewed bell curves. In a symmetric bell curve, the mean, median, and mode are all the same value. How easy is that? But in a skewed distribution, the mean, median, and mode are all different values. And these are the types of skewness. There are a positive skewness and a negative skewness. As you can see in the graph, in positive skewness, the extreme data values are larger, which in turn increase the mean value of the data set. Or in the simple term, in positive skew distribution is the distribution having the tail on the right side. And in the negative skewness, the extreme data values are smaller, which decreases the mean value of the data set. Or the negative skew distribution is the distribution having the tail on the left side. And next is normal distribution. Normal distribution is a probability distribution that is symmetric about the mean. It is also known as Gaussian distribution. The distribution appears as a bell-shaped curve, which means the mean is the most frequent data in the given data set. Here, we see the 4 characteristics of a normal distribution. Normal distributions are symmetric, unimodal, and asymptotic, and the mean, median, and mode are all equal. A normal distribution is perfectly symmetrical around its center. Standard normal distribution, when in the normal distribution mean equals 0 and the standard deviation equals 1, then normal distribution is called as standard normal distribution. Normal distributions are symmetrical in nature. It doesn't imply that every symmetrical distribution is a normal distribution. Normal distribution is the probability distribution without any skewness. And next, comparing negative, positive, and normal distribution in a graph, it will look like this. And now we will talk about the tests of skewness. Skewness is present if the values of mean, median, and mode do not coincide. Second, when data are plotted on a graph, they do not give the normal bell-shaped from, that is when cut along a vertical line center the two halves are not equal. Third, the sum of the positive deviations from the median is not equal to the sum of the negative deviations. Fourth, quartiles are not equidistant from the median. And lastly, frequencies are not equally distributed at points of equal deviation from the mode. And next we will learn about measuring skewness. Skewness can be measured using several methods. Pearson mode skewness and Pearson median skewness are the two frequently used methods. The Pearson mode skewness is used when a strong mode is exhibited by the sample data. If the data includes multiple modes or a weak mode, Pearson's median skewness is used. And here is the formula of Pearson mode skewness, where x equals mean value mo equals mode values equals standard deviation of the sample data. And the other method is Pearson median skewness. The Pearson mode skewness is used when a strong mode is exhibited by the sample data. How to interpret? Skewness also includes the extremes of the dataset instead of focusing only on the average. Hence, investors take note of skewness while estimating the distribution of returns on investments. The average of the data set works out if an investor holds a position for the long term. Therefore, extremes need to be looked at when investors seek short-term and medium-term security positions. Skewness risk occurs when a symmetric distribution is applied to the skewed data. The financial models seeking to estimate an asset's future performance consider a normal distribution. However, skewed data will increase the accuracy of the financial model. If a return distribution shows a positive skew, investors can expect recurrent small losses and few large returns from investment. Conversely, a negatively skewed distribution implies many small wins. Usually, a standard deviation is used by investors in forecasting returns, and it presumes a normal distribution with zero skewness. However, because of skewness risk, it is better to obtain the performance estimations based on skewness. Moreover, the occurrence of return distributions coming close to normal is low. And the formula to find skewness manually is this. In order to use this formula, of course, we need to know the mean and median. As we saw earlier, the mean is the average. It's the sum of the values in the data distribution divided by the number of values in the distribution. You may be asking, what is the importance of skewness? The important question arises what we will do after finding the skewness. Skewness gives the direction of the outliers if it is right skewed. Most of the outliers are present on the right side of the distribution, while if it is left skewed, most of the outliers will present on the left side of the distribution. But the important thing to keep in mind, it doesn't tell about the number of outliers. Let's take a look at the summary of this topic, which is skewness. First, skewness measures the deviation of a random variable's given distribution from the normal distribution, which is symmetrical on both sides. Second, a given distribution can either be skewed to the left or the right. Skewness risk occurs when a symmetric distribution is applied to the skewed data. Third, investors take note of skewness while assessing investments' return distributions, since extreme data points are also considered. And now we will see some skewed distribution examples in real life. First, cricket score. Cricket score is one of the best examples of skewed distribution. Let us say that during a match, most of the players of a particular team scored runs above 50, and only a few of them scored below 10. In such a case, the data is generally represented with the help of a negatively skewed distribution. Similarly, a positively skewed distribution can be used if most of the players of a particular team score badly during a match, and only a few of them tend to perform well. Second, exam results. The representation of exam results forms a classic example of skewed distribution in real life. The distribution of scores obtained by the students of a class on any particularly difficult exam is generally positively skewed in nature. This is because due to the increased difficulty level of the exam, a majority of students tend to score low, and only a few of them manage to score high. Similarly, the distribution of scores obtained on an easy test is negatively skewed in nature because the reduced difficulty level of the exam helps more students score high, and only a few of them tend to score low. Third is average income distribution. Income distribution is a prominent example of positively skewed distribution. This is because a large percentage of the total people residing in a particular state tends to fall under the category of a low-income earning group, while only a few people fall under the high-income earning group. The mean of such data is generally greater than the other measures of central tendency of data such as median or mode. And the next example is the human life cycle. The human life cycle is a classic example of asymmetrically distributed data. This is because most people tend to die after reaching an average age, while only a few people die too soon or too late. If such data is plotted along a linear line, most of the values would be present on the right side, and only a few values would be present on the left side. Hence, the representation is clearly left O. And the fifth example is taxation regimes. Due to the unequal distribution of wealth and income, the taxation regimes vary from country to country. Most of the people pay a low-income tax, while a few of them are required to pay a high amount of income tax. The distribution is clearly asymmetric in nature. Hence, such data can be represented easily with the help of a right or positively skewed distribution. And the next example is real estate prices. Real estate prices can be represented easily with the help of skewed distribution. Usually, most of the houses, plots, buildings, etc. have a lower value, while only a few of them are incredibly expensive. This means if the prices of all the real estate options available in a locality are plotted along a linear line, more values will be plotted on the left side, and only a few values will be plotted on the right side, thereby forming a tail on the right side. Hence, it forms a prominent example of a right or positively skewed distribution. And the last example is distribution of stock market returns. The representation of stock market returns is usually done with the help of negatively skewed distribution. This is because the stock market mostly provides slightly positive returns on most days, and the negative returns are only observed occasionally. Hence, the graphical representation of data definitely has more points on the right side as compared to the left side. And that's all for this video. I hope you enjoy it and I hope it can be useful for you, and don't forget to give a like and comment to this video. Thank you.